Hi, I'm Patrick, and welcome back to the standard What's in Your Box training series. In this installment, we're going to talk about how advancements of internal combustion engines have led to more sensors under the hood and how critical those sensors are for systems like variable valve timing, turbocharging, gasoline direct injection, and even stop-start technology. Now, it's no secret that car makers have introduced multiple technologies to help improve fuel economy and reduce emissions. These systems have created new opportunities, including VVT solenoids, turbochargers, GDI injectors, and high-pressure fuel pumps. But these newer systems are also dependent on accurate real-time data, and that's where the sensors come in. Variable valve timing uses a cam phaser and oil-controlled solenoids to quickly alter the timing to optimize performance and fuel economy. But where does it get its data from? It's from the camshaft position sensors and the crankshaft position sensors. And in addition to measuring the position and speed of the camshaft, these sensors also tell the ECU if the camshaft is advancing or decelerating. The accuracy and speed of these sensors is critical to the performance of the VVT systems. And that's why our sensors are designed, tested, and manufactured for accuracy, speed, and durability. Almost 50% of new vehicles are equipped with a turbocharger, and some vehicles have two. You already know that turbochargers don't just operate at full boost all the time. So how does the ECU help manage the speed of the turbocharger? Well, it depends on real-time data from both the mass airflow or MAF sensor and the manifold absolute pressure or MAP sensor. The MAP sensors tells the ECU how much air is entering the intake, and the MAP sensor tells the ECU the pressure of the air entering the engine. The data is also used to determine the amount of fuel required under specific boost conditions. The accuracy of these sensors is critical, especially the MAP sensor, as it's measuring airflow in grams per second. Now, some lower cost MAP sensors may only be tested and calibrated on a bench which can't simulate real world conditions. We've developed an advanced method for simulating airflow at speed in the lab, and we also test MAP sensors on actual vehicles at various altitudes for optimum performance in all conditions. Fuel pressure sensors aren't a new category, but direct injection has made them more important. Modern GDI engines actually have two fuel pressure sensors, a low pressure sensor between the fuel pumps and a higher pressure sensor in the fuel rail. The precision of these high pressure sensors is critical as they have to quickly adjust from 500 to 3000 psi. Our fuel pressure sensors are precision engineered and tested to optimize performance and fuel economy. Lastly, I want to talk briefly about battery current volt sensors and why they've become more crucial. They're sophisticated sensors, often measuring the battery voltage, the current, and in some cases, the temperature of the battery. These are critical as many vehicles now incorporate smart charging, which can reduce the engine load from the alternator to improve fuel efficiency during normal driving. The system also helps determine if the battery or auxiliary battery is prepared to handle stop-start restarts. These modern systems depend on accurate real-time information to operate correctly, and Standard has you covered with sensors that are engineered, tested, and manufactured specifically for accuracy, speed, and durability. World-class engineering, manufacturing, detailed lab testing, on-vehicle performance validation, leading coverage, industry-leading training and sales support. That's what's in our box. What's in yours?